Hey, good evening. My name is Derek Solberger, and I just felt like here late at night, recording a video where I take on Advent of Code. Advent of Code is a series of computer programming puzzles that are released every December, and we'll dive right into it. But first, on the left side of the screen, I just wanted to introduce myself. Hi, again, my name is Derek, and I'm a data science instructor. I mostly focus on teaching, and by no means do I consider myself to be an expert at computer programming, or at least not compared to some of the other people who are making videos such as this. I'll be using the R programming language because that's what I use most of the time, but I do dabble in Python as well as some of the other languages that you might need for document making, such as LaTeX and Markdown. So today we'll look at day one of Advent of Code here in 2021. Hopefully, we'll be able to solve both puzzles, let's say within an hour. And because I know that there are others who will be making introductory videos, or not introductory videos, but making expert videos and tweets, I actually thought I would go after a different audience and keep this at an introductory level. Maybe for my own sake, but also in case there are programmers who are just getting into Advent of Code and computer programming puzzles in general. So this is for you. At the bottom left, you can see that I'm not going to be aiming for time efficiency or space efficiency in computer programming, and I'm definitely not going to be aiming for the leaderboards, considering as of the time of this recording, the leaderboards are already full. Alright, so let's go ahead and get a sense of what Advent of Code is. Today's day one. The title of the puzzle is Sonar Sweep. You're minding your own business on a ship at sea when the overboard alarm goes off. You rush to see if you can help. Apparently, one of the elves tripped and accidentally sent the sleigh keys flying into the ocean. Before you know it, you're inside a submarine. The elves keep ready for situations like this. It's covered in Christmas lights, because of course it is. And it even has an experimental antenna that you should be able to track the keys if you could boost its signal strength high enough. There's a little meter that indicates this antenna's signal strength by displaying 0 to 50 stars. Your instincts tell you that in order to save Christmas, you'll need to get all 50 stars by December 25th. Collect stars by solving puzzles. 2 puzzles will be available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. So that's the overall theme of Advent of Code. Each year starts off with a paragraph or a set of paragraphs like that, where there's a ruse, a story that's related to Christmas and how you have to save Christmas by getting 50 stars. And apparently, the stars power this antenna that will help us search the sea for the sleigh keys. We could discuss more about Advent of Code if we do more videos like this, but if you're still here, I want to go ahead and dive into today's puzzle. As the submarine drops below the surface of the ocean, it automatically performs a sonar sweep of the nearby seafloor. On a small screen, the sonar sweep report, your puzzle input, appears. I'll go over what your puzzle input means in just a couple minutes. Each line is a measurement of the seafloor depth as the sweep looks further and further away from the submarine. For example, suppose you had the following report: 199, 200, 208, etc. This report indicates that scanning outward from the submarine, The sonar sweep found depths of 199, 200, 208, 210 units, and so on. The first order of business is to figure out how quickly the depth increases, just so you know what you're dealing with. You never know if the keys will get carried into deeper water by an ocean current or a fish or something. To do this, count the number of times a depth measurement increases from the previous measurement. There is no measurement before the first measurement. In the example above, the changes are as follows. So from 199, we're just starting from scratch. There's no before measurement to consider. From 199 to 200, the depth increased. From 200 to 208, the depth increased. However, now a couple steps later, from 210 to 200, the depth decreased. As we follow this example down, we see that the word increased literally appears 7 times. In other words, in this example, there are 7 measurements that are larger than the previous measurement. And our task at hand is to answer how many measurements are larger than the previous measurement. As a caveat, I will fully admit that day 1 of an Advent of Code group of puzzles is intentionally made to be easy. I think the designers make the puzzles, or they design the puzzles well in that the difficulty starts off easy and then the difficulty increases as you go from day 1, day 2, all the way up to day 25. So hopefully we will be able to solve this. Now, in these computer programming puzzles, the input is usually quite a lot to see, and it would not, in most situations, would not make sense to display them on this same website. So you click on puzzle input, and you can see that the so-called sonar sweeps that we're going to be looking at happen quite often. What I like to do is I have a folder, technically a GitHub repository, where I want to keep all my work for Advent of Code. There are multiple ways to deal with the input, but I'm going to do this in a way where I could stick to my own computer. This is year 2021, December 1st, so I'm going to give it a file name where I specifically say on this day we have some input. I'm going to copy and paste all the numbers into this text file. Now, long story short, the copy and paste tends to put a space at the very bottom of this file, and in previous adventures of solving these computer programming puzzles, this extra line could actually cause an error somewhere, whether it's a compile or runtime error. So I'm going to get rid of that last line and stick to the numbers that were actually displayed. Save that. And now I'm going to open up RStudio. For myself, I like to work in an R Markdown document. So I'm going to open New File, R Markdown. Give this a title of Day 1. And old habit, I like to have the date update whenever I update the files. We might bring in code packages later, but we'll worry about that later. For now, in a hasty way to document the code, I'm going to literally copy and paste the puzzle and the instructions into my document. And then before I forget, I should save as. I'm going to go to my Advent of Code file. I like to keep my own naming convention. So year 2021, December 1st. This is an R markdown file. So I'm going to give it an extension .rmd. We're going to insert a code chunk. That is where to type the code. The keyboard shortcut is Control-Alt-I. And I like to literally name this first variable puzzle input. To deal with the text file, I like to use the readlines function that comes in what we call base R, the version of R that you have when you install R on your computer. And because I keep a consistent naming convention, I happen to remember my file name. But it's probably even easier to take a file name like that, copy and paste it in between the quotation marks, just to make sure. I'm going to run this line of code with Control-Enter. Now, there is a warning because of that stuff that I said earlier, because I got rid of that extra line. The warning says that there's an incomplete file line. I assure you that this is actually better for the Advent of Code puzzle solving process. But our studio itself thinks that this is something to warn us about. And we could get back to this later if need be. On the top right, we see that the puzzle input has been brought in, and there are 2,000 of what are called characters. That is, this 173 is being treated as a word, not a number. Same thing with the 178 and so forth. So that's something that we're going to have to contend with. So to do convert character strings into numbers. But also, the Advent of Code puzzles are usually phrased and set up in a way where before we do huge calculations on, say, a list of 2,000 numbers, it's usually better to do calculations on a smaller example first, just to make sure everything's working. So we recall, back in the example, we do have these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers that we could use. I'm going to copy that back in my Advent of Code folder or directory. I'm going to make yet another text file. 2021, December 1st. I'd like to call this example.txt. So it's a separate text file. Paste the example numbers, make sure that there's no extra white space or extra lines. And the reason I do that is because I want to have a version of the input where instead of drawing the huge list of numbers, I'm going to instead draw just the 10 numbers from the example. So you see in the top right corner, we have just 10 numbers to contend with. Alright, so this will bring us back to how we have strings instead of numbers, and the reason why that matters is because we got to subtract numbers. Subtracting strings or subtracting words does not quite make sense. So what we're hoping for is in the programming language you're using that there is a way to convert from character strings to numbers. I'm going to call this vector puzzle numbers, and I'm hoping as integer works for what I just described. So now puzzle numbers, let me keep the code on screen. I'll pull up the contents of puzzle numbers here at the bottom left in the console. And now you can see that we have our 10 numbers, and they are no longer wrapped in quotation marks, because the computer now understands that we do indeed have numbers, and we could do calculations such as addition, subtraction, multiplication, and division. That bit of code is done. Next, I'm thinking in the long haul how I want to show you what's going on. There are plenty of people who will write one line of code that will do everything to solve this problem, and that's fantastic. But for novice programmers, I want to try to be more deliberate about what I'm doing here. So, like I said in the introduction, I'm not going for efficiency. Instead, I'm going to try to show you step by step what is happening in the calculations. In R, one of the main ways to store data is in a structure called a data frame. For now, you could think of that as a spreadsheet like you would see in a software program such as Excel. Out of an old habit, I like to call my data frames DF. It's not the best idea, but it'll be good for now. And to do that, we have a command called data frame, and we're going to store the puzzle numbers. You'll see at the top right, data frame DF has 10 observations and 1 variable. If I click on DF, we'll see our original list of numbers from the puzzles example. Now, we recall that the instructions are how many measurements are larger than the previous measurement. One way to think about this is if we look at the numbers again, it might be easier on this side. If we look at the numbers again, we know that 200 is 1 unit larger than 999, or 199. We know that 208 is 8 units larger than 200. That is, if we perform subtractions from one number compared to the previous number, we could tell if there's an increase, if the result of the subtraction is positive. However, to go from 210 to 200, the change is negative 10 units, because 200 minus the previous number would be 210. There are ways to do the calculation we want really explicitly, but maybe this first time around I'm going to see if there's a shortcut. what's the programming language you're using, you're hoping maybe there's someone who's already done this particular step. The phrase is do not reinvent the wheel. So I'm going to Google something like how to compute differences in list of numbers in R. Now I literally put that into a web search. How to compute differences in list of numbers. And then because I'm using the R programming language, I end the search with in R. The search is pointing us towards a function called diff. We could look at the documentation through the websites that we encounter, or we could go down here in the bottom left of the console and type $diff, and the documentation will now appear in the bottom right. There are some examples available in the documentation. I'm going to skip ahead a bit and show you here in the bottom left what happens if we calculate the diff of puzzle numbers. Well, we know if you could see the original list of numbers and the differences, we could see that the difference between 199 and 200 is 1 unit. The difference between 200 and 208 is 8 units. The difference between 208 and 210 is 2 units. And we mentioned before that the difference between 210 and 200 is negative 10 units. So I want to keep these numbers in mind somehow. And personally, I want to try to put that in our data frame back up here in the top left. So suppose that if I'm going to make a new column, of differences. I'm going to call this say change in the number. Now I'm going to use that line of code that we tried below, the diff of puzzle numbers. In case any of you are screaming at your screen right now, yes, I'm going to either run into an error right now or I'm doing something intentionally incorrect. But just to show you, the viewer, what's going on, I'm going to run this line of code. I'm pressing Control Enter, or you could use this green play button at the top right of the code chunk. And it reminds us that this difference calculation that we got before had only 9 numbers in it. But we had 10 rows originally to contend with. So our studio is already telling us, I don't want to do that, Hal. Or, what's the reference? I'm afraid I can't do that, Hal. And cannot put the 9 numbers we want next to the 10 original numbers, nor did I tell our studio how to do that. Going back, now I kind of wish I could take away that movie reference from my video. Oh well. Going back to the puzzle, what I'm aiming for is to try to make a data frame look like this, with a reminder that the first element should be empty in some sense. So in my code, I'm going to concatenate, or loosely speaking, combine the NA, the not applicable symbol, in front of my differences of numbers. And this time around, no errors pop up. Looking at my data frame, if you see there in the top left, the differences now appear as intended. Going from 199 to 200, increase of 1. Going from row 4 from 210 to 200, and change in negative 10 units. Okay, so now with these numbers in mind, just quickly, if you haven't already, ask yourself, how do we know if the submarine's depth increased or decreased? And you quickly gather that we are looking for positive numbers for the increases. Now, for this next bit of code, I'm going to use techniques from a realm called the tidyverse. So yes, I probably should load that up. It's the tidyverse, in case you are unfamiliar, is a suite or collection of code packages that are meant to work together well. That is, they're highly compatible with each other. The codes tend to be easy to type because the naming convention, or how we type the codes, are pretty uniform as well. I'm going to go ahead and run this line of code. R is going to tell me some more warnings that will not affect us today. Now, what I want to do is classify differences as increase or let's stick with the puzzle grammar, increasing or decreasing. So this next bit of code, maybe it's not useful to say what it all does right now here in the first day, but another way to make a new column, I'm going to call this change, and I'm going to say we're describing the change in words. If let me look up something real quick. I want to make sure I recall how to type this. There is a way to combine an if statement with the mutate, but I also want to do this in a way that makes sense to introductory viewers. So let me actually save that for a different video. Instead, I'm going to use capital N to store however many numbers there are. So in the top right, you see our puzzle numbers list has 10 numbers in it. And I just wanted to keep a copy of literally that number 10 and store it as a variable capital N. So you now see in the top right, capital N says 10. I'm going to create another column called change word, And for now, I'm going to fill it with the NA symbol n times. That is 10 copies of n. Let me show you what it does here in the bottom left. Repeats the NA 10 times, like that. When I run this with the code that affects my data frame, now I have this third column where I can now insert the words increasing or decreasing. We're going to skip the first row and fill in the words as needed. The expert programmers, again, have much more clever ways to do this, but for today, for an introductory session, we'll use a for loop. For row numbers 2 to n, from row number 2 until the last one, we're going to look at the current number is given by this bit of code here. We're looking in the change number column at this row number. And then for the previous number is one row above it, so you subtract 1 from the row. If the current number is greater than the previous number, then in the current row, we're going to put the word increasing. I'm going to read that again. If the current number is greater than the previous number, then we are going to put the word increasing in our data frame. Similarly, if the current number is less than the previous number, we're going to put in the word decreasing. Finally, there's a third case. If the two numbers are equal to each other, neither increasing nor decreasing, I'm going to leave the code as is, and what will happen is that the result will still be at the default not applicable. To run this for loop, I'm going to select the for loop and then press Control Enter like usual, and something went wrong here. I accidentally used the change numbers. Because, sorry, I combined a couple of thoughts. So, a lot of this is salvageable. It's just that I feel a little embarrassed because if I was really good at video editing, I would slice the video right here and say, okay, we're right back to where we're supposed to be. This for loop was not formed correctly, so I'm going to comment that out. But there are lessons in mistakes. It's one of my old science teachers from back in high school gave us advice that you never erase your mistakes, you only cross them out. Part of the reason is so you don't make the same mistakes again. Okay. It turns out the thought process that I had prescribed a while ago was correct. I just didn't actually code it that way. So we said if the change number is positive, put the word increasing. If the change number is negative, less than 0, put in the word decreasing. And then otherwise by default, the not applicable NA will stay there. Instead of selecting the whole for loop, I could just leave the cursor at the last brace, press Control Enter to run it. And I made another mistake. It turns out I accidentally called the whole entire change num column. We only need one number at a time. So we need to specifically tell R that we're looking at just that row number. And then finally that should work. So now, similar to our puzzle example, see if I could bring that up again. We have increased and decreased. Sorry, I did not completely line that up. And now we just need to count the word increasing. So the word increasing should appear 7 times. The way to do that in R is we're going to look at that column, which is called change word double equal signs increasing. What that's going to do is either true or false or not applicable tell us in which locations did the word increasing show up. Now, you may have heard that computers treat the words true or false as 1s and 0s. So if I converted that to as integer, then we have 1s where the word increasing appears. And then finally, more towards the puzzle goal, we have the sum of this, what we call a logical statement, which will, which should produce the number 7, but I still have an error here because I am contending with a missing value, and R does not automatically deal with missing values. There's a parameter called na.rm equals true. It says remove the missing values before doing the calculation. And now we get the 7 as intended. Especially if we encounter longer bits of code, I like to put in a nice statement, a print statement, which will, 1, help me document the code, 2, just shore up everything nicely, and 3, if I come back to this several days or months later, I'll remember what I was doing. Let's see, so we're looking for, in the puzzle instructions, how many measurements were larger than the previous measurements. Okay, so this statement should say there are 7 measurements that are larger than the previous measurement, and there we go. So from start to finish, we brought in some numbers, we converted the input into and made sure that there were numbers, found out how many there were, and we stored the information in a data frame. So we calculated the change in consecutive numbers and then classified the changes as either increasing or decreasing. Moreover, I am satisfied that the code works for the example. The question is whether this code will work for the real puzzle that was given to me. I'm going to toggle commenting keyboard shortcut in RStudio is Control-Shift-C. I'm going to toggle out the example input and now bring in the real input with the 2000 numbers. If everything runs okay, n should be 2000 and the data frame should be larger. I'm going to go ahead and press the green run button and run all the code into chunk. I'm going to show you that this is now what we're contending with. And you probably noticed in the bottom left that for my puzzle input, I got my answer out of it. This number will probably not work for you. And that's to the credit of the folks over at Advent of Code. I'm going to input this number back into the website to see if I got it right. And that is the correct answer. We did it. Yay. But let's not rest on our laurels. Let's go ahead and continue to part 2. So now part 2 says, considering every measurement isn't as useful as expected, there's just too much noise in the data. Instead, consider sums of a 3-measurement sliding window. Again, considering the above example. Let me go down here. Start by comparing the first and second 3-measurement windows. The measurements in the first windows are marked A, 199, 200, 208. Their sum is 607. The second window is marked B, 200, 208, 210, and their sum is 618. The sum of measurements in the second window is larger than the sum of the first. So this first comparison increased. Your goal is now to count the number of Your goal is to count the number of times the sum of measurements in this sliding window increases from the previous sums. So compare A with B, then B with C, C with D, and so on. Stop when there aren't enough measurements left to create a new 3-measurement sum. In the above example, the sum of each 3-measurement window is as follows. Like so. In this example, there are 5 sums that are larger than the previous sum. And then the overall task is consider sums of a 3-measurement sliding window. How many sums are larger than the previous sum? So what I'm going to do, what I'd like to do is when I'm given a part 2, just for the sake of quick documentation, I'd like to copy and paste this into my R Markdown file, save every once in a while. And the puzzles are, my setup is going to start the same way. I'm going to form a data frame. Once again, caveat, it's not the most efficient thing to do. It's just, I think I'll be able to show you what's going on more easily. We're going to, once again, start with the small example, the 10 number example. Convert the strings from strings to numbers and load the data frame. So our data frame, once again, has these 10 numbers. Now, like the example here, what I want to do is to build these window sums, that is the sums of each 3 consecutive numbers for us to look at. For loop for row, because we need 3 rows to start off with, we're going to start in row 3, go to n, and I want to make new columns. First of all, window sum. We're going to make a space for that, and the words increasing or decreasing, we're going to make some space for that. So now the data frame has these 3 columns and gives me some room to work with. So for a row from 3 to n, I want the window sum to be. So what I'm trying to do, let me show you here in the bottom left, is I'm taking the puzzle numbers, the first one plus the second one plus the third one. And that gets the 607 mentioned in the example. Here in the bottom left. That gets this 607. Next, if I go from the second number to the third number to the fourth number, that's going to get the 618. And so forth. So I want to use this code but the row numbers will change a bit. So we're going to start with a certain row number, and then we're going to go to I got this in a backwards order. We're going to, let me start it down here. We're going to have a certain row number. We're going to use the previous row, kind of like we did in the first half of the puzzle. And then we're going to use the number from 2 rows previously. Going to run this code. And I forgot to also save this in the correct place. This should also be pointing at a certain row number as well. And now, those 792s at the beginning shouldn't be there. Let me rerun this entire block of code again. Because let me start the data frame from scratch and then run this for loop. Now look at these numbers in the middle column, 607, 618, 618. Those are the numbers that we see here in the example. So just like in part 1, our next step is to then classify the changes. So just want to double check what I'm doing here. Now, the first possibility of a change happens in row 4 because we have the first 3 numbers and then the next 3 numbers right after that. Let me bring up the example again. We have the first 3 numbers labeled capital A in the example, and then the next 3 numbers going from rows 2, 3, 4 in the example, and we don't perform a subtraction until we reach row 4. So I'm going to start off this sequence at row number 4. We are looking at, now let me bring in this stuff I tried to do before. Current sum is the window sum at this particular row number. Previous sum is the window sum in the previous row. So if current sum is greater than previous sum, then the word that we want in this row is, I'm going to stick with increasing. Then if the current sum is less than the previous sum, we're going to plug in the word decreasing. So let me check if this all works out now. Looking at my data frame, we see the words increasing and decreasing. Let me compare that to the example. Increase, no change, decrease, increase, 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 increase. So, barring a slight gaffe in grammar, we have the correct classifications. And then let me bring in the print statement at the very end. I called this window word this time. I'm going to run this all again to see that there are 5 measurements that are larger than the previous measurement, and that matches what the example said. Now that I am satisfied that this worked with the example, what I'm going to do is toggle off the example and toggle on the puzzle input. I'm going to run this. There's technically nothing wrong with me showing answers online because the folks at Advent of Code are usually create several different puzzles, but still, if I could avoid showing the answer, that'd be great. So let me move some things around here. And also, I'm not even sure if I'm going to get the right answer. So let me see what I want to keep on the screen right now. Maybe that and that. And there we go. Let me run the code. I'm going to double check to see if that works in the website. And voila, we are done. We got our pair of gold stars here on the first day of Advent of Code. So, if you're viewing this now or in a later time, I want to thank you for being here and giving me a chance to bring this material to you. Until next time.